Hello class, today we'll be looking at counting sort. It's a kind of linear sorting algorithm we use to sort integers where the range of the values distribution is not significantly larger than the data to be sorted. All right, so it's a non-comparison sorting algorithm, and it's based on the range of the input values. So you need to do some data analysis before you apply counting sort. You need to look at the range of the input values, look at the differences between the minimum and the maximum to know the range, and ensure that this difference is not significantly larger than the number of elements to be sorted. It's different from comparison sorting algorithm, such as the quick sort, the merge sort. All right, counting sort takes advantage of the properties of integers and performs the sorting in a linear time. All right, so we're going to see how it works. First, you find the minimum and the maximum values in the array, and this helps to determine the range of the array elements. Here is a clear example. You have an array right here. So look at this array and determine what the range would be, right? So the range right now is from 0 to 4. If you look at it, there's no value in this list that is greater than 4. Because of it, we create the counting array to be from 0 to 4. Then this counting array would be populated by the frequency of each of these values. For instance, 0, count the number of times you have zeros here, put the value here. Count the number of times you have ones in this array, put the value here. Count the number of times you have 2 in this array, put the value here. Count the number of times you have 3 in this array, put the value here. That is your counting array. Okay? So that is what is being described in this place. You determine the range and you create a counting array, which is like a frequency array. All right. Now, having done that, you need to modify the counting array by doing subsequent addition. In other words, if this was the original counting array, I'm going to bring down 2. Then I'm going to say 2 plus 1 is 3. I'm going to put a 3 here. See that? Then 3 plus 2 is 5. I'll put a 5 here. 5 plus 2 is 7. Put a 7 here. 7 plus 3 is 10. Put a 10 here. See that? So this is the modified counting array. And that's what I will use to now determine where each element will go in the output array. So the output array will be of the same size as the original array. The original array size is 10, right? So we create an output array of size 10, index 0 through to 9. All right? So we'll now be scanning the original list. We scan the original list. When you find an element, go to the modified counting array, look at the index of that element, then place that value in that particular index of the output array. Then you reduce the modified array count by 1. I mean, that index that you just applied, you reduce it by 1. You keep scanning the input array and you repeat the process. When you find a value, you go to the modified counting array, look at its index, place that value in the output array, in that particular index, then you reduce that modified counting array value by 1. Okay, we're going to see how it works shortly, and we'll do some examples. All right. So these are the steps. Create a counting array to store the frequency of each value. Now modify the count by adding the previous number. Then create output array by decrease count array. In other words, it is the modified array that you're going to use to determine where each element will go in the output array. Thereafter, you decrease the count of the modified counting array. All right. So let's look at this as an example. Okay. So we have 1, 4, 3, 2, 3, 5, 2. All right. So now you create a count array, the range will be from 0 through to 5 because that is the values you have, right? It's not more than 5. So 0 to 5. And that's what you get here. Then the frequency of each of the elements, we populate it here. And that's why we have this guy 0. 0 is not found in this place. So 0 is going to be 0. 1 is 1 here. 2 appears 2 times. So it's going to be 2. 3 appears 2 times. It's going to be 2. 4 appears only 1 time. It's going to be 1. 5 appeared only 1 time. It's going to be 1. Okay. Now you will now modify this count array. So this is it. This was the original count array we had here. You see that? This was 0, 1, 2, 2, 1, 1, right? So that's the same thing you see here, 0, 1, 2, 2, 1, 1. Okay, so now we modify it by adding the subsequent value. So we're going to bring it down this 0. Then we're going to say 0 plus 1. You see that? 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 1 is 6. 6 plus 1 is 7. So we have modified the counting array now to get the modified values, and this is what you get. Now, when you want to create your output array now, it is this modified accounting array that will determine where each element would be located. For instance, you have this, okay? Now, there's something I want to say here, that the property of counting sort would be stable if you scan the input array from right to left. It will not be stable if you scan the input array from left to right. All right? So take note of that. Stability has to do with the placement of the values, the order of the placement of the values. So for instance, if two values are the same, you want to make sure that their original order is regarded. In other words, if I have 2 here and I have another 2 here, these 2 should always come before these 2 when I finish my sorting, right? If these 2 would always come before these 2 when the sorting is done, then we call it a stable sort. All right. Now, if this 2 does not come before this 2, instead this very 2 is coming before this 2 after you finish sorting it, then we're going to say that your sorting algorithm is not stable. All right. So with that said, we want to start our scanning. Okay. Let's disregard stability for now. Let's just scan from right to left, right? But we know that as you are scanning let's scan from left to right. You know that as you are scanning from left to right, then your output sorted array will not be stable, all right? So this is the output, right? So let's start. So you start from here, 1, right? So you go to that value 1, look at the modified counting array. What is the element in it? The element is 1. You go to the output array and you place 1 in that very location where you have 1. You see that? Then you continue to scan. All right? You continue to scan. When you scan to 4, you go to this 4. Okay? Then this 4, this is the sum array, right? So it's not a modified array. So let's look at the modified array and see what you get from the modified array. Is 1, 3, 5, 6, 7, right? So that's what it should be. So this should be 1, 3, 5, 6, 7. So this should be 6, 7, all right? This should be 6, and this should be 7, okay? All right? So this is what you get. Then immediately you place this 1, all right, here. This guy should not become 0. See that? So that means this guy will no longer be valid. You see that? This guy will no longer be valid. Rather, this is what will be valid, 0. All right. Then we'll now move to 4. when you get to 4, you go to look for 4 in the modified counting sort. So you said it's going to be 6. We go to 6, we place the 4 here. See that? Place the 4 here. Then let me increase the font and okay. So now having done that, having placed the 4 in this 6th position, we'll reduce this guy to 5. Okay, so this is going to be 5. So reduce it by 1. So this guy will no longer be valid. Okay. Then you continue to scan. Then we'll scan to where we have 3, right? 3 here is 5. That means I'm going to place 3 here. See that? I'm going to place 3 here. Then I will increase the font. Okay. Then my 5 will now become 4 because I'll reduce it by 1. You see that? Reduce it by 1. So this is going to be 4. See that? So that's the... Okay. Let me create enough space here. Okay. So now I know that 4 is my value right now. Okay. So it's no more 5. Then I'm done with 3. So I'll go to 2. When I get to 2, I'll look for 2. 2 is in 3. Okay. Take note of this 2. Okay. This is the first 2 I encountered, right? So 2 will be placed in 3. See that? I mean 2. 2 will be placed in 3, right? So now having placed that, let me increase the font. Let me just change the default font to be. So now I'm going to say this guy will now become 2. You see that? So what I'm going to do here, I'm going to strike this. Okay. Then I'm already here, right? So I'm already here. Then I'm going to move to this 3. You see that? I'm going to move to this 3. Remember the first 3 we encountered. The first 3 we encountered, we place it here, right? We are encountering another 3 now. That's to tell you that when you are scanning from left to right, it's not going to be stable because this 3 now will be going to the position 4. We're going to the position 4, and that's a problem because this 3 in the original list did not come before the previous 3. You see that? This 3 should not come before this 3. You see that? So now this guy, it's just the same process. You're just going to strike this one out and reduce it to 3. 3. See that? Now this 4 will be gone. See that? This 4 is gone. Okay. Now you have 3 here, right? So we are left with 5 and 2. When we get to 5, what do? You go to where you have 5, and 5 should be at the location 7. I put the 5 here. That should be 5. See that? 5, right? Then this 7, I'll reduce the 7 to 6. 6. Okay. So this 7 should be striked out. Okay. 6. Then this 4 also, I think I struck. It's not working. Okay. That's fine. Then I will now move to 2. See that? Move to 2. Then when I move to 2, I would look at 2 and see where I'm going. So 2 should be 2, right? So I'll place this 2 here. See that this 2 now is not coming before the previous 2, which is not supposed to be. See that? So then this guy will now become 1. See that? So that's the idea here. With that said, when you finish all this operation, you realize that you are done doing your sorting. See that? So let me okay. So I believe with that, you can see that the data is sorted already. But though the data is sorted, but it is not sorted in a way such that the output will be stable. In other words, the data you sort did not respect the initial order. This 2 initially is coming before this 2, but now this 2 is coming before this. So in order for you to avoid that, you want to start scanning from this side, right? So instead of you placing this guy here, this guy should start from this place. When this guy starts from this place like this, you do the same procedure. It's the same thing. You will see that it will be sorted. At the same time, it will be stable. All right. So that's it with respect to this one. All right. So these are like, you see the way it works. You see the way it works. See the way it works. See the way it works. Right. So that's it. That's what I just explained to you. Okay. Then this is going to be the final sorted list. Then this is the code. You can see that you have multiple for loops, but they are not nested. Because they are not nested, we can see them as, k number of for loops. You can see it's n plus k, right? So at the end of the day, this is what you're going to get at the time complexity. And because we don't pay much attention to those constants, we just consider the n. So this will be big O of n. You see that? So that's it with respect to counting sort. If you have any question, just let me know.